interaction with the vehicle. So we'll test ergonomic features to understand reach and comfort inside the vehicle, and then we'll look at visibility concerns to look at what you can see, up vision and down vision, so what you can see, like if you're looking at a stoplight or if you're looking over the hood and looking around the vehicle, and we'll assess the driver's likes and dislikes. So the whole focus of this lab is about making sure that we're satisfying the customer's likes and dislikes. We don't do engineering testing like crash tests or things like that. It's really about the customer's relationship to the car or truck. So if you want me to explain the technology now?
Sure.
Okay. So what you're seeing here is a programmable vehicle model. So this is an adjustable vehicle that can grow and change to any vehicle Ford is thinking of producing. So right now it's set up in a configuration of an F-150, and then we marry this physical structure with the virtual world, and we actually lay the virtual data over this physical model, and we give you displays to put on your eyes. We have this head-mounted display, we call it. So you have computer screens on your eyes. We track where your hands are, and we let you interact with the vehicle. And in this environment, you have all those key touch points that are germane to what we need to study. So we'll have gas and brakes, steering wheel, dash, the center stack where sometimes you put your arm, the door, so we can test belt line, and we can move the door up and down and gauge what's comfortable for you. And so we do all that testing in this environment.
We're driving all the time, right?
Yeah.
All the time.
All right. And so here are your eyes. So you're going to put this on, and you have left and right stereo.
Okay.
And these markers are going to track where your head is, and then these are tracking where your hands are. So do you see a street? Yep. Okay, go ahead, grab the wheel. It's there.
Okay.
So you virtually, you see your virtual hands grabbing the virtual wheel.
Oh my god.
And then your physical hands are grabbing the physical wheel, and it all lines up.
That's crazy.
So you can take your arm and like put it on the door. Like, go ahead, look.
Oh.
And then if you do this, you'll see you have that.
Oh wow.
That's the contour of the door represented.
Oh my god.
Right, you got it. And so now this is the driving configuration of the F-150. But now everything you see is...
You're looking like a car model touching the side.
the Cheryl Merrill.
Ford. Oh wow.
And then if you, like, even if you make that backup maneuver, so turn around over your right shoulder, like grab the wheel, yep, do that. Yep, no, just no, turn your whole body, and then you can see, like, out the back.
Oh wow. Here comes a car.
Yeah.
But you can see what I'm
when she comes
When she
back.
comes back.
No, we can see you.
Oh, you have no idea?
No, we can see, you guys can see what she's seeing over here.
Oh, you see it?
Oh,
That's
okay.
her. That's one eye. It's not in stereo, but it is showing what she's seeing. So go ahead and look up at the rear view mirror. And then Dan's going to turn it on. And so you'll start to see reflections.
Oh wow.
And then he'll adjust it for you. Is it adjusted? Yep. And so those are the real-time reflections being generated.
So how real does it feel? Does it feel like you're in a real car?
It does. It's crazy.
I'll give her the sunshine.
Yeah. Okay, now look ahead, and your visor is going to come down, and the light changes.
The light changed.
We'll just toggle it.
That's no, it's 5.
Yeah, that's right.
There you go.
No.
You pull into like Starbucks and get a coffee?
Oh.
Yeah. But the whole point of this is so that we can evaluate different door configurations. So Rich can raise and lower this door, and then she can physically put her arm on here and feel that this is a comfortable driving position. And then she can also gauge visibility. What can she see? What can't she? If a design was modified slightly, would it provide better visibility or a better driving experience? And why? And so we'll move the data around and then physically move this. So she'll sit in here and she'll hear, and it's this vehicle adjusting to a new dimension, and then we'll study that dimension. So she'll have a different seated position in the vehicle. You all set?
Yeah. It's awesome.
All right.
Okay.
All right, there you go. So you're inside.
Oh, what bad luck. A bucket of water.
Yeah, right, yeah.
Why is there a bucket of water in here?
Sorry, Jeff. You didn't really want that camera, right?
Nah.
Yeah, right.
So if I like push on the gas, will it like move and stuff?
No, no.
I got some funny tracking going on in a hand.
Okay.
Yeah, it's doing this.
Which hand?
It seems that I have.
Left hand is goofy.
I can't really go.
There we go.
Did you try the other one?
Yeah.
So if I turn around,
I've tried this.
Yeah. See what you can see.
wow, you can watch this truck pass by.
Yep. Exactly. Yeah. It's just.
Look in the rear view mirror.
Amazing.
We already got the rear view mirror.
What scene am I in? Is this somewhere in Detroit or? Just have to ask.
Yeah. No. It's some. Is it which world? Oh, that's just a world we bought off the web. I don't think it's any particular place.
You bought this off the web, really?
Well, the world.
The world.
Yeah,
Not the
not the
world.
vehicle, but the
Yeah.
world.
So you saying Ford won a world?
Yeah, Ford bought world. We actually own two worlds. Ford owns two worlds.
So I keep asking this. I have to ask you how much does all this equipment cost? If I wanted to put this in my bedroom and really have some fun.
Well, so there's the virtual and the physical
Okay.
cost. So the tracking cameras, the head-mounted
Make out the back
display,
Exactly.
computers, and all that stuff to do the virtual part is like 150K.
Okay. How about on the physical?
And then on the physical side,
It was. So $1 million to have this